None of us understand what's coming, and we must in order to act with integrity today. When I say that, you likely think of politics first, which makes sense, but I'm a biology teacher, and there are things happening and coming that could make all politics irrelevant. While they're connected, and I'll get to that at the end, for now let's zoom out from the individual trees and look at what's happening with the whole forest. Talk about a couple of things that mostly only scientists are paying attention to today. The beginning of this may be familiar, but it builds to pieces I expect you're not aware of, and we must be. Many people understand that CO2 emissions are concentrating in the atmosphere, causing climate change. That's true. It's also a little misleading, because it turns out CO2 has been concentrating somewhere else that is arguably much more important, and that's the ocean. The ocean has been acting as a giant sponge, soaking up over a quarter of emitted CO2. Quarter may not sound like much, but there's a fallacy of scale to beware of there. We're currently producing about 40 billion tons of CO2 annually. The ocean's been absorbing about 10 billion tons per year. That is the total amount of CO2 that we were producing annually on this planet in 1965. There's two things to be aware of around this. The first is that the rate of CO2 accumulation in the atmosphere has been drastically slowed. In the next couple of decades, the sponge is going to get full, and the rate of CO2 going straight into the atmosphere is going to skyrocket. It'll be the equivalent of multiplying our current CO2 emissions by over 1.25, and that is with CO2 emissions continuing to rise every year. The other piece of this is what it means for the ocean. Salt water absorbs CO2 in a way that makes it more acidic. You may have heard the term ocean acidification. That's an effect of oceanic CO2 absorption. What does it mean that the ocean is turning into acid? Well, as with any vast ecosystem change, we genuinely have no idea, but there are a few details we know, little things, like the fact that every form of marine life that makes a shell, from clams to barnacles to coral polyps, which make coral reefs, use calcium carbonate from the water to make their shells. And there is a pH threshold under which calcium carbonate shells can no longer exist in seawater for the same reason that a loose tooth will dissolve in a cup of soda. The acid melts the calcium. Once ocean acidification crosses that threshold, then marine life will not only be unable to make new shells, all the shells in the ocean will dissolve and crumble. There will be no more clams or crabs or coral reefs. That's not just a seafood shortage. Mollusks, like clams and oysters and barnacles, are the liver of the ocean. They are filter feeders whose ecological role is to keep the water clean. And they do that on a scale that human infrastructure just can't even imagine. Mollusks live on like every inch of shoreline other than the polar caps, and their absence will be a literal sea change of what the ocean is. Ocean acidification at the scale we're facing will trigger full-blown ecosystem collapse that will affect all life on Earth. In many ways, this is more serious to the biosphere than atmospheric CO2 for a couple of reasons. Past what we just covered, did you know that over half the oxygen you breathe is not converted by trees or land plants? It's converted by marine plants, mostly phytoplankton. Hard to say exactly how ocean acidification will affect phytoplankton. In any changing system, a couple species thrive, and maybe things will be great for them. But pH changes are rough on plants in general. Most plants evolve and can only live in a pretty narrow band of acidity. So if ocean acidification and the subsequent marine impacts are bad for phytoplankton, which they very likely will be, we could lose half of the produced oxygen in the atmosphere. Oxygen constitutes 20% of the atmosphere at sea level. There's a bunch of variables that could affect this. We really don't know, but let's just take that for a spin by the initial math. If we lose half of the oxygen and the oxygen concentration crashes by 50%, that could make sea level oxygen levels fall to 10%. That is the equivalent of the oxygen level 3.5 miles in the air, like at the top of Mount Kilimanjaro or Denali. I don't know what percentage of the population could survive at those oxygen levels, but the impacts of this kind of oxygen collapse on its own, without any other variables at play, would be apocalyptic. So I can't tell you how serious global marine ecosystem collapse would be for two reasons. First is that I literally cannot imagine it myself. And the second is that no one knows. No one knows what's coming, and no one can imagine how serious this is. Add to that some of the effects we can predict around coral reefs. Coral reefs provide natural organic wave breaks throughout the equatorial zones of this planet. We're used to waves in the Caribbean or the South Pacific being at 2 to 10 feet on average. Storms push them up to 20 or 30 feet. Some areas have much larger, some smaller. But that baseline is created by coral reefs. And when the reefs dissolve, the baseline of shoreline waves will be multiplied by some number that's hard to estimate, but it'll be larger than 1. Even if it's only 2, which is a wild underestimation, that means we're looking at 4 to 20-foot waves as a baseline. That's full storm-level waves, 24/7. If it's 5, that means a baseline of 10 to 50-foot waves. We're talking beyond hurricane-level waves, 24/7. The unmitigated force of the open ocean is so far beyond what most people can conceive of, and without coral reefs, it will be unleashed on the coasts of the equatorial shorelines of this planet. Storm surges are going to become apocalyptic in coastal communities and drive erosion in ways we can't imagine. Add to that sea level rise. As a scientist, let me explain something about science. By its nature, science is wildly conservative. Science, especially predictive science, needs to stand up to hardcore scrutiny and peer review. So it can't say most of what is true. It can only say what can be absolutely proven. That means that all predictive models are extreme underestimations of what's about to happen. And there's no better example of this than the common understanding of how polar ice melt relates to sea level rise. At the polar caps of this planet, there are billions of metric tons of ice suspended in shelves hundreds to thousands of feet above sea level. When scientists began predictive modeling, they calculated the temperature rise and how quickly that temperature would melt the ice. This was pure, demonstrable, indisputable math, and it painted a dire enough picture that any sane person would see the need for action. It was in the 70s through the 90s. And they watched, and what did they see? As soon as the ice started to melt, just a little, all that thawing water flowed down between the cracks in the ice and lubricated the bottom, turned frozen ground into mud, and created growing pockets of water under the ice sheets that destabilized it and immediately began breaking them apart, sending huge chunks crumbling into the ocean. So rather than a mathematically steady melting of ice under increasing heat, like an ice cube sitting on a table in a room, what's actually happening is an exponentially accelerating collapse of the entire ice sheets. And remember, the ice doesn't need to melt to raise the sea level, it just needs to fall. On this note, the combination of factors in climate change are beginning to collapse the Gulf Stream, the ocean currents of the Atlantic. This is not futuristic, this is happening now, and it's the first domino in the collapse of the Atlantic Meridional Overturning Circulation, or AMOC. Despite the name, this is a global ocean current that looks like this. It's why the west coast of Europe and the west coast of the US are so much warmer than the east coast of the US, despite being at the same latitude. It's also why 90% of the trash in the ocean spins around at the same spot in the Pacific, in a trash country twice the size of Texas. Anyway, the Gulf Stream and then the rest of AMOC collapse. Ocean currents, and therefore climates, are going to become chaotic and unstable. The coast of Europe and the west coast of the US will get much colder. East coast of the US, where I live, will get much warmer. This is one of many reasons that the scientific community doesn't tend to call climate change global warming anymore. It's more commonly called climate destabilization. This is why we're already seeing an increase in ocean storms, and that's only going to grow in our lifetimes as AMOC crashes. The unimaginable power of the ocean is going to break free from the consistent currents that it's danced in for all of human history and begin just smashing around in unchecked and unpredictable ways. The storm surges that we discussed becoming apocalyptic with coral reef collapse will happen more and more often. Seasonal patterns that have defined ecosystems around the world will become wholly unreliable. Let's be clear, this is already happening. Last summer, here in my home of Maine, we received less than 2 inches of rain all summer. It was an extreme drought, technically, the likes of which I've never seen before. This is a rainforest. Nobody thinks of it that way because it gets cold, but it's really wet here. This summer is predicted to be the same level of extreme drought. That's 2 years of extreme climate that my home has never experienced before. We've had dry years, never like this. Permanent springs, dry for months. Wells collapsing, full of dust. The forest floor, which should be soft, damp moss and leaves, crumbling to fine powder and puffing up around your feet as you walk. But let's be equally clear. What we're seeing is the very tip of the beginning of what's coming. We are about to see what global system collapse looks like. The process of land becoming desert is called desertification, and climate change on top of global corporate monocropping will drive that like a blowtorch to dry leaves. There is nowhere on this earth that it will not touch. Much of New York City will be underwater within my natural lifetime. I will live to see the last moose and the last new maple tree in Maine. The examples of this are endless because what's happening and what's coming touches all parts of the biosphere. It's hard to describe how fast the climate is changing. Just a couple very quick examples. When I was a kid driving down the road at night, it was just a world of insects. You had to run the windshield wipers every couple minutes to clear off all the smushed bugs. Today, a bug hitting my windshield at night is kind of a rarity. That is the collapse of the foundation of an ecosystem. And it is going to have a domino effect up the trophic levels and will impact everything. When I was a child, there was regularly 4 to 6 feet of snow on the ground here in the winter. These years, rare to have more than 6 inches on the ground. 4 inches of snow is now called a blizzard. When I was a kid, that would be a flurry. Blizzard meant multiple feet at once. I'm not even 40. 20 years ago, I saw negative 40 degrees on the thermometer. Often, every winter, we had months where it didn't break zero. Today, sub-zero temps are a rarity. For climate to change that fast, that visibly, within a human lifespan, let alone a mere decade, is like light speed climate change. In a stable climate, change like that takes centuries at least. Climate change is like falling over a round waterfall. As you fall, momentum builds exponentially. We are getting to that point of exponential acceleration. Let's look at these things together. With the collapse of AMOC, we're going to see pockets of ocean stagnation. Water that was moving will now sit. The primary filter organisms of the ocean, the mollusks, will no longer be alive, so there will be a level of rot in the acidic ocean that we have never seen before. We're about to see a climate refugee crisis on a scale that no one is prepared for. We're going to see food shortages due to ecosystem collapse of arable land where you can grow things, and that's before we add other variables, and there will be other variables. Since industrialization, the percentage of an average human's diet that is cereal grains, mostly rice, wheat, and corn, has been steadily